Thank you very much. So today we're going to continue with our lessons for SQL. Last week there was something that I wanted to complete. I said, but time was not on our side. It's a very small bit of what we were doing last week. So we'll just quickly complete that, and then we would look into another part, which is also quite small, before we go into what we actually have planned for today. Right? So we would, let me just bring up my screen to share. Let me share my screen. What's this? Can you see my screen?
Yeah, we can see it.
Okay, cool. Let me create a new query. Right, so with this one, well, I think I'm not sure which database. I think we were using the SQL HR database when we did that last week. So it's just that bit that I just want to do is the use of order by, the order by clause. Remember, we said the select statement has got a format, select from where it follows like that. So we did the select, we did the select and from are the only two mandatory clauses. The other ones are added on as and when needed. So we have looked at the where clause and how to add it on. We're now going to look at the order by clause. That shouldn't take us, that should be like just 10 minutes. Order by. Now, the order by clause itself is, it has a default position in the sense that whenever you run a query, it defaults to a particular order on its own. So even if you don't add the order by clause, there is a kind of arrangement by which the results are produced. If the order by clause is not inserted, then majority of the time, or not even majority of the time, all the time, the order by clause would order based on the primary key. So what I mean, for example, is if I say select, if I, for example, say select all from employees, if I execute this statement, so there is an arrangement here as it is. Who can tell me what the arrangement is on?
From employee.
Pardon?
Is it from employee?
Yeah, from the result that we have here.
Pension ID.
ID.
Is on what?
The person
Pension
ID.
Well, it's on the person ID,
Yes.
which happens to be the primary key in this case. So if the order by, so the order by simply is a clause which is inserted to create an arrangement, or let me rephrase, to create a desired arrangement. If that clause is not inserted, then the arrangement defaults to a position. Here you see that it's arranged in ascending order. That is the default position. Now, that default position happens to fall if there is no specification, it falls on the primary key. However, that default position can be altered. So if I, for example, say that if I say Select this, select everything, and instead of ordering on the primary key, order by, let's say, surname. Surname. So now we want to change the arrangement onto surname. So you see that first we had 00001, right? Now the arrangement is on the surname, and it's ordered on the surname in alphabetical order, starting from A. Starting from the letter A, just as you would arrange a list of students in a class register. Right. So again, you would see here that the arrangement is defaulted to ascending order, where if A is taken as the smallest and Z is the largest, then it starts from A all the way. Let's see if there is a Z in this. There isn't a Z, but there is a Y. Okay, so that is what we have here. Now, so if we were to write this statement as that, order by, this is the specification for ascending order. If we were to specify this, do you think there will be any change at all in this arrangement? If we run this, will it be different from that? Let's try it and see, but keep an eye on the first and the last. Just take note of that. If there is a change, you should see, or let's to make assurances double sure, keep an eye on the first three, Abbott's, and Abomedi, or something like that, and the last three, so that there is no confusion. Wilden, Wilson, Young. Let's see if there will be a change at all in that order if we run the query on this specification. Is there a query in the first three here?
Yes,
is there
no?
is there a change in the first three, and is there a change in the last three?
Yeah, the first three is not changed.
No,
What about the last three?
there's none.
So can we conclude that there was no change?
Yes, we can.
We can. So can we conclude that this statement and that statement are one and the same?
Yes.
Yes, it's
Yes,
giving
we
us the same
can.
results. Yes.
So can we then conclude that when you just want your order by in ascending order, you really do not need to specify this there. You don't need to put the ascending specification, because that is the default position. Okay. However, if we were to do this, let's see what is going to happen with this. This is the descending order. Straight away, you see that the names, what we had what we had in the last part, Young, Wilson, and Wilden, have now become the first three. And let's go and see whether we would have the first three that we had previously as the last three. That is what we have as the last three. So that has changed. So in much the same way, we can choose any of the columns and order on. In this particular case, we have ordered on surname. You can choose to order on first name. You can choose to have a mix of attributes to order on. But if you do that, okay, let's try one. Let's just try one. Let me use this first. Surname. Okay, instead of surname, let me put first name. First name. Is it all together? Is it together or is it hyphenated? Forename. Okay, so that's his forename that is there. So that's what we have to use. Forename. Forename. Forename, surname. And let's see. Watch this carefully and see if you would be able to say, or can somebody say where the order by would start from? Let's run this. No, not this one. Let's run this and then see what we have. So we have Rita Abbott, Laura Abbottis, or whatever pronunciation you can give to that. And let's run this and see. What has happened? Can you see something has happened?
Yes.
What has happened?
So we've got it in it's sort ordered it by the forename.
It would first order by the forename. It will first order by the forename. So where you have, for example, Alan Cox and Alan Masood, it orders the Alan, and then it takes into consideration Cox and first Alan. Then these two names are ordered also in ascending order. Do you get that? So where you have multitude of the same first name, it would order the first name is already set. Then it comes to the column of the surname where it now orders everything in the same order that you have asked it to order. So for example here, Anna, then it comes to Hoda and Ume. It will not take Ume before it takes Hoda. Never will that happen. Okay. Right. So let's go on and then let's get the next. So that is the order by clause. We finished with the order by clause. Let's go and see the other bits that we want to do. Aggregate functions. Aggregate functions. One moment, guys. Let me just mute myself briefly for a second. Okay. Right. So we're going to look at aggregate function. I asked the question, who knows what aggregate functions are? Nothing strange about these aggregate functions. Actually, they are your normal maximum, minimum, sum, average, count, average, count. I'm not sure if there is any other one. Yeah, these will do actually. These 5 will do. Let me switch database so that we use something new. First of all, let us see what we have in that table. You remember this statement, right?
Yeah.
Okay, so let's select everything and see what we have in that table first of all. Then we can decide on what we want to do with it. Why did it not run? Select all from. Yep. Okay, so this is what we have. Let's see, can we run aggregate functions on any of these? On any of these attributes? Can we run aggregate functions? Can we find maximum? Can we find minimum? Can we find sum? Obviously, this is a key, so we can't find those things on this. We can't find, yeah, we can, but it's practically of no use to us. As a matter of fact, employee national ID. No, that's we don't want to know much about their ID, their employee national IDs and stuff. But I think if you were to be doing aggregate functions, you'll be looking more at things like salaries, prices, sales values, and things. Those are the things that will be of concern to you. So let's see if we can find any of such, and then we can run functions, aggregate functions on these. Base rates, yeah, we can run on base rates. We can even run on vacation hours, sick leave hours. This is an employee table. So yes, we can find who was the person who was sick the most of the time, or how many people were sick most of the time. We can do all of those things. So let's see if we can, yeah, let's use sick leave hours and see. Let's find the maximum sick leave hours. So how do we write that query? We just write the word max, which stands for maximum, and then in brackets, we put the attribute name. The attribute name must be written as it is in the table. So we have said we want to run on sick leave hours. So we must run it as sick leave hours. Maximum sick leave hours from employee table. We want to see the maximum sick leave hours. And what has that given us? That has given us 80. So the person or the persons with the most sick leave hours clocked 80 hours of sick. 80 hours of sick. We can use another table to find, we can use another query to find who this person or these persons are. And I'm going to go do this in the simplest form, because there is we could do what is called, I could do it in one query by what is called subqueries, but we haven't done that yet. So I'll do it in a different form. So let's see. Select. Let's select first name. Is it first name we have. How is how is it written in the table?
I'm guessing phoname. Is that what we've got?
Let's see. Let's check. Let's just check. Yeah, first name, last name. Okay, so let's select first name, last name. First name. Select first name, last name. First. Last name. Why am I writing this like that? N-A-M-E, N-A-M-E. From the table we are using is deem employee. And then we know what the maximum sick leave hours is. So what clause do we use? Well, sick leave hours is equal. Do you remember this kind of query?
Yeah.
The where clause, yeah?
Yeah.
We can use this to find who that person or persons. And with Rob Roberts, it looks like this person appeared twice in the table, in the database. Rob Walters, sorry. So yeah, that's a person who is the most sick in the organization. And we can find the minimum sick hours also. We can find the minimum. All we do is to change this to mean. And that is 20. Somebody is very generous. 20. Now let's use this on another table and see whether it would work the same way. Let's see. Let's go into the database and see what table we can choose.
Godwin, sorry, can
Yep.
I ask a quick question?
Yes, do please.
Okay, so one of the queries, not one of the queries, the one we just ran, the one with the where sick leave hours equals 80, and the result was to Rob Walters. I
Yep.
think when we're looking at the whole, or when I was looking at the whole table, I think there were two employee numbers. So does that mean that there might be two separate individuals within the
It's possible.
organization
That's
with
what,
the same?
yeah, you know, I said that it does look like there are two Rob Walters in the table.
Okay. So how do
Or
we
maybe there is a duplicate.
Okay.
So that could have actually been inserted. You know, that could have been inserted there for cleaning purposes,
Okay. So if there's
right?
separate employee numbers, so how do we differentiate? How do we? Okay.
So
So
when you are cleaning, assuming you were to be cleaning, you realize that you have you remove duplicates. So you just remove one of the values, one of them.
okay. Sorry, I put myself on mute. Okay, I heard what you said. Thanks.
Yep. Right. So let's see if we can use another table, another table there that would make sense. I want something that will give us, let's see something that has got to do with money. We all like money, right? Okay, let's use finance or sales. Let me see. Internet sales, finance. I'm more let's look at finance. Let's look at finance. Finance key accounts. Amounts. Okay, amount looks like a decent thing to talk about. It might give us scope. So let's use the finance, fact finance, okay? So select all from fact finance. And let's see what is there. Fact finance. Let's see what we have under this. Right, so these are the things we have there, right? Let's see what we can do with this. Let's see if we can find the maximum amount, the minimum amount, the average, the sum, and the number of. Take note of something. How many rows do we have in this result?
11.
Can somebody, pardon?
11 row. No, oh, no, it's not 11.
3,330.
Yeah.
3,330. Who said 11? You're just looking at this small window.
Yeah, that was
This
me.
is where the result is.
Yeah.
Right? Okay. I intentionally asked that. And please put that figure in mind. We would come back to it when we run another query. We'll come back to it. So let us see if we can get the maximum. Select maximum amount. Select max. Remember how we write the maximum query? Brackets, brackets. In the brackets, the attribute's name. Maximum amount, let's see what we have. So this is the maximum amount we have in the table. And that's what figure is that? 14,923,275.30. Right, so let's see the minimum amount. We're going to run all of these together. Mean. I like writing my keywords in caps. Let's run both together. And we have, this is the minimum amount. So there were some losses. Okay, no problem. Businesses make losses, don't they? So yes, it's understandable that there is a loss. So let's see the sum of sales or amount, total amount generated. Sum. You want to calculate the whole sum, the total of everything. Let's see what we have. Min, max, sum. This is duplication, isn't it? I want to run all of these together. So we have, okay, let's do something. Let's do something. As max amount, maximum amount. Let me put it max amount. As min amount. As sum. That makes more sense, doesn't it? So it looks more presentable. And let's do another one. We want to find the average of everything. So assuming your managers, tell me what was the average sales for this month? Average sales. So you just go into your database and run the average. Cool, and present to them. They will be looking at you as if you're a magician. Wow, this girl did this thing in less than 1 minute. Average. Average as average. So this is the average value, average amount generated in the sales table. I don't know whether it's by product. I don't know whether it's by region. I don't know. I've not looked at that. But that's what we have. We know that's the average generated in the Facts Finance table. Now, how many sales value? How many values do we have all together? That is where we use the count. We want to find the total number of values that we have in the table. That is where we use the count. Remember, I told you to keep a figure in mind. That is the figure we have here. Okay, that's the figure we have here. Any questions so far?
No question.
Thank you. Any questions, Temi? Any questions? Let me see if I can.
So, Godwin,
Yes.
can I just ask, why do you have as sum as mean amount? What's the
Okay.
relevance of the as, please?
Okay. I think I mentioned this in a previous lecture, right? You remember the day we spoke about aliases?
I think I missed that class. I do apologize for.
Okay. So let's just run this query, okay? And see what. Let's just run this query. Okay, let me do 2. So these are the results. Now, assuming you were asked to produce a result of some figures, would you present the results, the result in this manner to your manager?
Sorry, how do you mean? I can't seem to. I can see the figure.
Does this make sense?
No.
No, because you only have figures and doesn't actually tell you what these figures.
Exactly. It doesn't tell you what they are.
Yes.
It doesn't tell you what they are. So this is. Let's run this again and see if it will make sense. Does this make sense?
Yes, it does. Yes.
Cool.
Thank you.
So that's what these are for. So the as is used in SQL to create aliases. Not all the time. It's used in, but most of the time it's used in creating aliases. Alias. So you have an alias, right? Who has the question?
It's myself, Timmy.
Tell do you have an alias?
I would
Do you
say
have a
yes.
nickname?
Yes, well, yes. I say yes.
Yeah. Okay. So take these as nicknames or aliases or some other name given to
Okay,
something. Yeah.
sure. Thanks so much, Godwin.
Cool, no worries. Any other question? Any other question? Dun, 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 dun.
I want to ask a question.
Yes,
Sorry.
please do.
Yeah, I don't know, is it right to use the alias as same as the reserved word? I don't know. I don't know if you get what I mean. The reserved word for some, the alias is some as well. Is it right? Is it okay to
Let's see if it will change anything at all.
okay?
Um, the point is, it really doesn't matter. So long as the as is there, it is something different.
Okay, now I get. Thank
Yeah?
you. Yeah, I get now. Thank you.
Do, 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 do. Any other question before I go to the next thing that we want to, what was originally planned for today? What am I writing? Who has come across the concept of joins in SQL? Who have come across joins?
Well, not particularly, but I think from the last internship, I heard the DA talking about the left join, the right joins, but not that I've actually, I understand what it means, but yeah.
Okay.
Yeah.
So joins simply, all right. So for example, we have the fact finance table, right? And let's also assume that we have, okay, not even assume. Let's say we have the sales territory also table. We can decide to join these two tables. Now, when we join them, they don't get joined within the database, but we have a temporary table of the join. And we can produce that as a result and export into whatever other framework we have and work on it. So for example, supposing we join two of these tables, we want to work with two tables and we join them together. We join the tables and we export into our Power BI. We can then start working on them within our Power BI if we decide to do so. Assuming we want to do a visualization of the two tables in our Power BI. Obviously, we can't do visualization in SQL. But assuming we want to do our visualization on two particular tables in our Power BI, then we can join the tables by whichever means that we desire, and then export the results into our Power BI, and then do our visualization there. Is that okay? Now, there are 6 types of join, 6 main types. There are a whole range of joins, but there are 6 types of joins. 6 main types of joins. There are 6 types of joins. Now, what are these 6 types of joins? The first one is just join. Join. The next is inner join. The third is, let me do this first, right join. Right join. Then we have left join. Then we have the full join. And then we have what is called the cross join, which you may never use. And then we also have what is called the self join, which you may also not use, but you could. So these are the 6 main types of joins that you have. Some people will tell you outer join, full outer join, full join, outer join, inner join. Right. How do we join? I'm going to use a simple, I'm going to use this table. Let me change the source of table. Let me change the data source. Should I? Okay. Or will it work on this? I think it should work on AdventureWorks. Right. Let's see what we have. Let's first of all see what we have in this. Select. Right. So in AdventureWorks, for example, let's see how we can join something. We have employees, right? We have employee, and we have do they have addresses? I am looking for a shortcut to this. 1, 2, 3, 4, 5. Employee. Okay, let me see what is in the employee table. Select all. Let me just see first. Select all from employees. from dim employee. Let me see what is there. Employee. One moment, okay? Let me work my head around this. Geography. Let me see geography. Sales territory. Go back to this. Employees. I want something simple to start with. Employees, employee ID, employee address. Yep, I think we can use this one. Is there an address table? Yes, there is an address table. There is an employee table. There is an address table. So assuming we want to find where our employees live. Okay, so that's what I want. Yeah, so let me change the database. For now, let me just change it briefly. SQL HR, select all from employees. Okay, so now, okay, so let's use this one. Here too, when you are doing joins, you might need to use aliases. So, and the reason is that if you don't use aliases in your joins, your queries or your statements could become just too long. They will become very long. So, for example, here I say select all from employees E. So I've used E to represent employees, okay? Inner join. Inner join. Now, what is inner join? What does it do? What does the inner join do? Maybe first of all, we should just run this query. And then we see what we have. This is what we have in this table. Now let's also run another query. From addresses. A. Let's also run. Okay, so let's run these two queries together and see what we have. So we have two tables here, two results. We have two results here. Look carefully at these two results. Are there some commonalities? Is there any common ground at all in these two results produced?
Yes.
What is the common ground?
Date time added. Date time modified.
Okay, can you find another common ground? Can you find another common ground? Look
Address
hard.
ID.
Look hard. Pardon?
Address ID.
Address ID. That's what I'm looking for. Now you see that there is address ID in the employees table. IDs would normally be either primary or secondary keys. In the employee table, address ID is the secondary key, but it's a primary key in the addresses table. So these two tables can be joined on that particular attribute, addresses ID. Do you get that? These two tables can be joined on the addresses ID. Now let's see what would happen if we join them. Select all from employees and inner join addresses A this is the syntax for the join. You have to put on what you are joining. You're joining one table on another. So you want to join addresses table in the employee. You want to join addresses in employee table. So in the employee table, which part of addresses will be joined onto the addresses table in the address table? Listen carefully to what I'm saying. In the employee table, which attribute will be joined onto the addresses table? Which attribute in the employee table will be joined onto the addresses table? It is the addresses ID, isn't it? So we take, what we are doing here is take employee table, select everything from the employee table and join the addresses in the addresses table on employees addresses, employee.addresses ID. Oh, come on. Employee.addresses ID should be equal to addresses in the address ID. Does this make sense? You are joining employee table onto addresses table. This is what this is saying. Join employee table onto addresses table. What are you joining them by? In their employee table, you have address ID, which you are joining onto the addresses table by the address ID in the addresses table. Does that make sense? Right, let me repeat. We have given employees here an alias E. And we have also given the employee table, we've given it an alias E. The addresses table, we've given it an alias A. Is that okay? Let's go back up. Let's go back here. This table, employees table, we are calling E. That table, addresses table, we are calling A. We are joining the addresses ID in the employee table onto the addresses ID in the addresses table. Does that make sense?
Yes.
Somebody tell me
Yes.
it makes sense.
Yes, yes.
Okay. So that is what this query is saying. Join the addresses ID in the employee table onto the addresses ID in the addresses table. These are the two tables that we are joining, employees and addresses, but we are joining them by their common attributes, addresses ID. And we are joining the attributes in the employee table to that same attribute in the addresses table. Okay, so when we run this query, let's see what we get when we run this table. Sorry, when we run this query. So inner join gives us this result. It gives us this result. Let me run all three and let's see if we can make any difference. Let's run all three and see it, except that it will be quite a lot and we might not see it very clearly. So this is the first one, second one, and the third. So you see the third has joined everything on the employees with everything on the addresses. Okay. Any questions so far? Any questions so far? Okay. Once you've been able to write your first, pardon? Somebody was talking. Is that Josh? Who was, somebody said something. I didn't hear the person.
No, Jack, no, I said,
Yeah.
you asked for questions. And, yeah, no, I
Okay.
said all good, no questions.
Okay, thank you. Thank you very much. The next one, let's do the right join. So once we've done this, once you've done one query like this, once you've been able to write one query like this, the rest is just chicken change. All you need to do is to change this word to whatever thing you want to do. So right join. RIGHT. RIGHT. Let's see. You run it. And it gives you this. I just want to run just this one. There is, however, an issue with the right join. There is an issue with the right join. Whilst it is good for you to know that there is a right join, it is not good practice to use a right join. And I would not advise you to ever use a right join. And this, if you have to go through an SQL interview, could be a potential question. The problem with the right join, how do you solve it? How do you solve the problem with a right join? Or should you, or they tell you, run a right join for us. How will you run a right join? And that could be a very, very tricky question. You just run a right join for us. And then you go ahead and you just write this query as it is. While the query itself is right, you run the query and you get the results, but its implementation will be marked as wrong because you don't do a right join. Simple as that. We would see why you don't do a right join. Look at this line, for example, 106. Hypothetically, and this has been put there intentionally. Hypothetically, look at it carefully. Assuming you are an employer and your employees, you've rented properties for your employees. All your properties must be occupied by employees. You have a property with no employee. The property is lying fallow. Does it make sense to keep a property that is not occupied for an employee? Does it make sense to keep a space and be paying for the place? Or does it make sense to be paying somebody who is not on the payroll? Does it make sense at all?
Yeah, no,
It can only
probably
make
not.
sense in places where you have ghost employees. That is the only time it will make sense. Right? On the other side, on the other hand, if it was addresses that were here, one could argue that you could have homes that are not occupied. But you can't have a situation where you have no people and then you have created, let's say, a salary for them, or you have provided them with accommodation that you are paying for. That does not make economic and realistic sense. So the right join brings out results that could potentially cause arguments. So it is not a good idea to run a right join. Okay, so the right join basically takes everything in the right table and joins it to matching records in the left table. That is the right join. And it is not a good idea to run a right join. We will see how we would go around a right join in a little while when we've done something else. What other join can we do? The left join. We can do the left join. Left. Actually, I want to run this also on the dim employee database and see. Okay, let's get something out of this first, and then we can, let's run this one and see what we have. The left join, does that give us any unreasonable results? Does that give us any unreasonable results? I don't see any unreasonable results. Every address seems to have been accounted. Every person here is accounted for and every address seems to have been accounted for. Even an address may be unoccupied. The address ID, for example, of this is not there, but it doesn't mean that there are no people. So that argument can be defended, but the previous one cannot, in monetary terms, be defended. Okay, so that's the left join for you. Now let's do some other examples on the AdventureWorks. Let me select this one again. Let's change the database a bit and see. Let's have a variety, okay? So that you're able to run it on your own. Right, so let's say we want to select. Guys, please close the door for me. Take these dogs away. Tell it to my dad. No, I'm in a lecture, please. Right, so we say we want to find something on DIM employee table, right? On the AdventureWorks database. So we use this one. Let me. It doesn't matter. I can leave this actually. And what do we want to get from here? It's not called employees in the DIM employee table. It's called DIM employees, right? In the AdventureWorks table, that is called DIM dimensional employees. So let's use the name as it is. Remember literals? We talked about literals. You must write your user-defined names as they are in the table. So select all from DIM employee, inner join, the same thing that we did. Let's say we join this. There are no addresses table in the AdventureWorks database on its own, but we have territory. So let's say we choose the territory table. DIM employee sales territory. Let's call that, what should we call it? Let's call it T. Okay. On. Okay. So let's run these two queries. Let's run just this one and that and see. So these are two different tables. Just like we did the first time. I want to see the commonality. I want to see the common feature we can select. Okay, so let's see we have this, and then let's do another one. Okay, so let's run just these two and see if we can find any common ground, just like we did the last time, okay? Is there any common ground? Is there any
Employee
common
key.
ground?
Employee key.
Yep, straight away you can see that employee key is a common ground.
Yes.
So we're going to use that to join the two tables, okay? We're going to use that to join the two tables. So let's take this again and put it back here. So just like the first time, we take the employee key, should be equal to the it should be equal to the sales territorial employee key, okay? Should be equal to the sales territorial employee key. Sales territory, sorry. Sales T dot sales territory employee key. So if we run this query, forget about these lines, these red underlined. Do you know where this comes from? Do you know why these are underlined? I
Yes.
believe we know why these are underlined, right?
Yes.
Okay. So when we run this table, this query, let's see what we have. So now we've joined the two tables together using the inner join, okay? In much the same way, we can do the right join, which I said we shouldn't do, just by changing this to right. Can change this to that. We are still inside this database, so it would work. And that gives us this one. And we can also do the left join. Okay. Right, so we've done three types of joins. The join, did we do join? I think we did join, just join. Did we do just join? Did we do just join? Did we do that? Inner join. No, we didn't do just join. We didn't do just join. Okay. That's okay, no problem. Join and inner join, they are just the same. The next one is the full join. Let's look at the full join. Oh no, let's talk about the left. Let's talk about how to go around the issue of the right join. How do you correct a right join? Who knows? Who knows how to correct a right join? Okay, so this is a right join that we have here. Let's see one of the right joins. This one, for example, is a right join. Let's see. Let's take it and bring it down here and see how we can work with that. This is a right join. Now, to correct a right join, what you do is you swap the leading tables. Swap the leading tables. So what is the leading table here? Dim employee. What is the leading table here? Dim employee sales territory. Swap them around. So this goes here, that comes there. And change right to left. Okay, so all you do is swap the leading tables. Swap the leading tables and change right to left. That's it. That's what you do. When you have a right join, that is what you do. And when you execute this, this is what you should have. Now let's execute it on this other table, on this one that had the null in the employees. Let's do that on here and see that becomes a little bit more clearer. So we said swap the leading tables. Swap the leading tables and change right to left. Why is this still underlined red? Why is it still underlined red? I thought it would have changed by now. Why is it still underlined red? Let me refresh.
Yeah, I guess it's still saying the
Yeah,
adventure
it's still
database.
seeing the other table.
Yeah.
Where is this refresh button? Refresh, refresh, refresh. Which one is refresh? Where is my refresh button? Okay, let me take this out of the way and see if it will change that. Okay, okay. That works. So this has brought it back to life. Okay, so let's run this one and see. So have we done that? We've swapped, right? Swap. We've swapped the tables, the leading tables, and we've changed right. Did we do that? No, we didn't. Did we do that? Employee addresses. Employee addresses. So we've swapped the tables, but I wanted to copy. I wanted to bring this back down here so you see how it changed. Okay, let me just copy and paste there again. What is happening? Right, let me run this and see what happens. So this was the query that we run the first time. Let's go back to line 106. And you see that that has changed. We got that statement. I wanted to, let me see if I can bring it down. Come on, I should be able to bring that down here. Where is it? Okay, right. Inner right. Okay, let me copy it again. Okay. So we have swapped the leading tables. Employees come down here, addresses go back there, go up there. And then we've changed right to left. When we run this query the first time, watch line 106. That is where we got that result, line 106. So it's the same query, but this time it has meaning because there is a high probability that you could have employees who do not have anywhere to live. So whilst this is very, very possible, right? This is very, very possible. There are employees, because we are working on addresses ID. In fact, they even have address. They even have address. It's only part of the addresses are missing. But the first time, it was just not reasonable, right? So this is more reasonable than that one. It's the same query, just written better. The same query written better. So this doesn't really make sense. You don't know what is there, nothing. Okay, so let's see, let's go on, let's make progress. Then the next one is the full join. The full join just says, so the left join takes everything inside the left and joins onto what is things on the right, so long as there is there are matching records. So they have to be matching records for them to match. But the full join, with a full join, it takes everything on the left or right and joins it onto each other, right? That is why it's called a full join. So sometimes the name gives you a clue to what the join does. Full join. Again, let's take and let's do full join. Instead of right, let's just put a full there. So that takes everything. And if you run these queries and then you check the number of rows, you see that for each one, there will be different number of rows. That gives you an indication of what has been produced in the results or in the output. Okay, so that's what we have here. We've done a full join and we had 137 rows. That's everything in the database. Whereas when we did the first one, we had like 109 at the time, we had 108, something like that. We can do the same thing on the dim employee table, and then let's do that also and see what we get. We can do a full join here too. It's just a matter of changing the left to full, that's all. The query itself is already written. That's the most important thing. Let's change the source. So that's a full query for that. Okay. Then the next query is the next type of join is what is called a cross join. Cross join. You might never come across a cross join unless maybe you are working in, say, the mathematics field, the field of maths, or yeah, you might come across that in maths or some other field where you have to do Cartesian products of things. Who knows what a Cartesian product is? Who knows what a Cartesian product is? Okay. A Cartesian product simply is your XY axis when you draw graphs, you have X and Y axis for your graphs, giving you, so when you map your X and Y coordinates, that's a Cartesian product. Okay? That's what a cross join does. So for this, I will use a different database. Let me see where I have that. So let me use First of all, let's run this query and see what we have. From these two tables, where are they? From these two tables. One and two. Okay, so let's run this. Cross join one. Cross join. How is it written? Cross join one. Cross join one. Again, it hasn't seen this yet. I don't know who. Okay, I've commented this one out. Okay, so if we run this table, this query, we get this result. The next one is cross join two. If we run this one, we get this result. If we run the two together, we get that. What if we do a cross join? These are separate joins. So no, these are not joins at all. These are separate tables, just like ordinary tables. So I could have called this cross join one table. I could have called it anything, but because it's called cross join inside of this database, that is why I've called it that, right? But I could have called it anything. I could have called it elephant. Select all from elephant. Select all from dog, right? It could be anything. It could be named anything. So now we are going to do the cross join. So let's cross join. So we select all from this and then cross join. cross. You need to use the term cross join. You have selected this table, cross join it to that table. So that is the cross join. You have this table. So select all from, let's say, select all from sales. Let's assume this is sales. Let me call it as sales. And this is as what should we call it? Geography, say. Right? As sales as geography. So cross join sales from, select from sales, cross join to geography. That's the way it is reading. Select all from sales, cross join to geography. Is that okay? So that's what we want to achieve from here. And that is what we have. And this gives us what is called a Cartesian product. So you would see that one, okay, let me run all three. 1, 2, 3. Let me run all three. That should give you a better idea. So one here maps onto A, B, C. Then 2 maps onto A, B, C. 1 maps onto A, B, C. 2 maps onto A, B, C. Same for 3 maps onto A, B, C. So if you have a table, for example, in the Adventure Works table, if you were to, what do we have there? Let's run a query here and see. Okay, let's just run this query and see what we have. How many rows do we have? Almost 300. 296 rows of data. If we cross-join this table to another table, let's say of another 296, or let's say 300 by 300, what is going to happen is that we would have the results that will be produced will be 300 times 300 rows, so that each one of these would map onto the other table this number of times. So that is something that will be very huge. So assuming you map 1 million onto 1 million tables, 1 million rows onto 1 million rows, that is going to produce how many, what is that? How many zeros in there? That will be 12 zeros. That will be how many billions? That would be huge, wouldn't it? That would be really, really huge. That's like 1,000 billion, isn't it? Right. So that is what we have with a cross join. So the cross join is rarely used, and it's used mainly in getting a Cartesian product of values. When you want a Cartesian product of values, okay, this has changed. So let me change this one. When you want a Cartesian product of values, that is when you use the cross join. And you can't use it if it's not like you can't use it, but it's not advisable to use it if you have a large data set. The last and final. Are we still here? How many people do we have? So nobody came again. Okay. The last and final one is the self-join. Self-join. What is a self-join? How does the self-join work? Is there anything called a self-join? Now, the answer to that is that in reality, there is no SQL statement that has got the word self. So the self-join is, in theory, not written as self, as self, using the word self, like the other types of joins. The only reason why it is called self is because you join one table onto itself. You join one table onto itself. What does that mean? So, for example, if I would, like in this table that we did, cross join 1. If I were to decide to join cross join onto cross join 1 onto cross join 1, I decide to join the table, sales table onto sales table. That will be a self join. But why would you do a self join? There are a few instances where you do a self join. When you want to show the structure or let me bring it down to organizational terms, like organizational charts. You want to show who is who in an organization, or how things really work in an organization. That is where you do a self-join. You want to see the hierarchy in an organization. You want to see hierarchy in a set of data. That is where you do the self-join. So you join the data onto itself to determine the hierarchy within the data. And in doing that, you don't use the word self. So there's nothing really like self in SQL. There's no keyword called self, but it's the way the operation is carried out that has led to the name self-join. So let's see a table that we can use. I have a table here that I think that we can use here. Let me see where I can find that table. Yep, I can get that table here. So this is a table that shows organization. It shows how it shows the power play in an organization. It shows the hierarchy of people in an organization. So I did say that the self-join is used in showing the hierarchy or the different data levels within a data set. That is where you use a self-join. So if you want to write a self-join, let's see what we can get from, let's say, this one. So let's say we select all, use. What do we use? Use SQL. Which table are we using? SQL training. Okay. We're still inside that database. Okay, let's say we take this one. Let's select all from this and see what we have here. First of all, before we go further. Right. So this is a table that shows the managers within an organization. It shows the managers within an organization. But how are these related? How do we know? For example, I believe we all work. Wherever it is that we work, we have our managers, and our managers have their managers, and their managers have their managers until you get to the CEO. Right? It's pretty much the same thing that we have here. Pretty much the same thing. So how does that work? To do a self join, we use the left join. That is the best way. I would have gone through all the types of joins with the self join to show you how it goes, but we haven't got time. We are already behind schedule. So I'll just tell you straight away, to do a self join, we use the left join, but we are joining the same table to itself. Remember the other types that we did different types of joins? We join one table to another table. But this time around, we want to join the one table to itself. So we use the left join for that. Let's see how we're going to do that. So we write left join. We want to join manager hierarchy onto manager hierarchy. But what attributes within this? We're joining this table onto itself. We need to, what attributes here can be joined? Okay, let me rephrase. Let me rephrase. Each manager, look at this table carefully. Each manager has got their own work ID, which is the person's ID. And each manager has also got a manager Each manager has got their own ID, and each manager has got a manager given by the manager's person ID. So, for example, if you take this person here, whose person's ID is 13, this person has got a manager with manager's ID and that is this person here. So we're going to see if we can join this attribute onto that attribute within this table. That is where it becomes a self-join. So join manager hierarchy. Let's give it an alias man to show manager on. So if the person this is a table of managers, but how will this person call that? Who can tell me? How will in work terms, how will Caroline Goodwill call Yvonne Smith? Official work terms.
Colleague,
No. Caroline is the manager of Yvonne. So how will Caroline call Yvonne? You want to join the manager onto oh, come on. How do managers call people under them?
staff,
Give me another word. Yes, staff would work. Staff is okay. Yeah, I will take staff. But give me some other word. Employee. Staff would ask, yes, staff. I will take staff actually. But let me go by employee. So we want to join the manager hierarchy, manager. We want to join manager hierarchy onto manager hierarchy. So the table is called the manager hierarchy table. We want to join the manager onto the employee. Okay? But the employee themselves are also managers. So they too have got manager person ID. So let's see, manager person ID. Manager person ID. This should be equal to the managers dot person ID. Employee dot manager person ID. Why is this still underlined? Where is this? Yeah, it's here. Why is this still underlined? What does this? The multi-part identifier could not be found.
I think we've not specified the emp.
Thank you. Thank you. Thank you. Yep, that's it. That was where the error was. So we've been able to, yeah, thank you so much. Yeah. With that small thing, you see how I was cracking my brains, thought I had made a mistake. That small omission. So we need to specify, given we are using aliases, we need to specify an alias for this also. So if we run this, this is what we have. Okay, let me run both, and then you see that it will make better sense. Let me run both, and then you see the sense that it would make. So this is the first table. Now you look at this carefully. You would see that here we said this lady, we said this is the manager to this lady, right? We said Yvonne's manager is Caroline. It shows clearly here. It shows here that Yvonne's manager is Caroline. But then we can also see that there is another level that we can still go. Who is Caroline's manager? Who is Caroline's manager? Can we go further? I think we can. I think we can. I think we can go further. Right, so let's say we want to select not everything at this time. Just let's say we want to select the employee person ID. M.person ID. Let's say we want to select the employee full name. Employee full name as M full name. And let's say we want to select their manager's full name. Okay. So if we want to do this, and we are taking this from where? From the manager hierarchy. Left join manager hierarchy man on employee dot manager person ID should be equal to manager dot person ID. Let's see if this would work. Let's see if we can run this, and let's see what we have. This is giving us something a little bit more precise. So here we know that this is that person's manager, that is that person's manager, that is that person's manager, that is that person's manager, that's that person's manager, and so on. But can we still take this a step further? Because this really doesn't show us the full hierarchy in the organization. Let's see if we can go a step further. Let's assume we want to find who the CEO is, who manages all the people. Let us call this CEO. CEO, the full name as CEO. So we want to call the person the CEO, right? And we're taking that from the manager hierarchy, who is an employee. Left join, everything here as before, but then we need to do another join. Manager hierarchy, CEO, on. We're now joining the CEO onto every other person. Man.manager. Person ID should be equal to CEO ID. CEO dot person ID. Is it becoming tough or tedious or let's see what we have here. What is this telling us? Okay, let me run these two queries together. That should give us some context. When we look at these two tables, are we still here or we've gone to sleep?
Still here.
Okay. So look at these two tables. This does not give you much information, except that you know that Yvonne's manager is Caroline. Alan's manager is still Caroline. But here you would see the full structure. You see Yvonne's manager, you see Caroline's manager, and you see the one person who has no manager. Why has that person not got a manager? For example, Caroline's manager is Stephen, but Stephen has no manager. Why? Because Stephen is the CEO of the organization. I don't think CEOs have managers, do they? Though they may report to the board of directors, but they necessarily don't have managers. Does that make sense? Any questions so far? Any questions? Do we have any questions? Who have I been sending the notes to? Is it Damisola or
Yeah, it's her.
Damisola, right?
Yeah.
Did I get the name right this time?
Yes, you did.
Okay, Damisola. Okay, so I'll be sending you the notes. So if there are no questions, we're already far behind time.